Okay, so the idea with this video is just to work through one of the three free response questions that you should have already done. The first two were there for you to check in terms of the solutions posted to the Canvas page. But this one, I think it's good just to get some review on a particular topic. This is the first of the non-calculator for this particular set of questions. So the first two you could use your calculator on. This one was a no calculator question because it was question 3. So they're giving you a table of information, which is really common for the AP to give you, and they're saying you're talking about minutes, so you're talking 6 minutes of time, and you're measuring the amount of a coffee cup that's getting filled. And they've used different things over the years in terms of what's getting filled, but they're going to be asking you just about rate of change on this one. So we've got C being measured in ounces. It's how many ounces are in this cup. And you can see that over time it's going up. So the amount is increasing. Using the data in the table, approximate the derivative at 3.5. So we don't have a function for it. We don't need to find a function for it. We just need to figure out from 3 to 4 what the rate of change is. And we're going to use that as our approximate. And then it says show computations that lead to your answer. So I'll just do that part A over here. So we're going to just find slope from those 2 points and then indicate units of measure. So we'll say what our units of measure are. So in this case, we're going to say, okay, well, the slope, or my C prime of 3.5 estimate, so we can say wavy equal sign, say we're approximating, is going to be the rise, which is 12.8 minus 11.2 over the run, which is 4 minus 3. And that means that we've got a 1.6, and that's ounces up top. And then on the bottom, we have 1, and that's minutes. Or probably more convenient way to write that is 1.6 ounces per minute. And that's it. So that's an estimate for it. You just pick the numbers closest on either side and show them that you're computing slope. And there's 2 points tagged with this one for the computation up here, and then 1 for the actual answer with units down here. Second one, we've got showing that from time 2 to 4. So let's see, I'll erase that little circling that I did earlier. So from 2 to 4, we're going to be looking at this segment of the table. Is there a time where the derivative is 2? So is there some point in time where the derivative is 2? So again, on this one, they're not actually asking for us to compute C prime, just to make some comment about is there a point in time where the derivative is 2. So what we're going to do on that one is, let's see, if we examine that rate of change, so let's do it the same way where we look at the rise, which would be 12.8 minus 8.8. That's just the 2 value and the 4 value, y values. And then we'll go 4 minus 2 on the bottom. So let's see, 12.8 minus 8.8. Of course, that would be 4. And then we have a 2 on the bottom. And that equals 2. And they're setting you up to get that. They want you to get that. So you're going to get a point tagged with just did you show them the slope computation. And then justifying your answer. This one they're asking for the justification. That you use mean value theorem. So mean value theorem says that on negative 2 to 4, I'm sorry, positive 2 to 4, can't have negative time. Well, we can, but we won't talk about that one here, and it's not necessary to the problem. So mean value theorem says from 2 to 4, there must be a t-value equal to the average slope. At least 1. It could be more, but we just need to say there's at least 1. So some explanation using the mean value theorem would be your second point on that one. So that's the first 2 portions, the first 4 points, and we'll switch to another color to do the third point here. So part C is saying use a midpoint sum with 3 subintervals, and I'll scroll up just a little bit. Actually, you know what we can do? I put a second copy over here, so let's pop over to this one. Just a clean copy that we can use to do C and D. So the midpoint, using a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate 1, 6, 0 to 1/6, 0 to 6 ct dt. So this is an average value. So that's average value. And then explain what that is in the context of the problem. So an average amount is what we're after on this one. So using a midpoint sum with 3 subintervals. So that means we're going to go from 0 to 2, and we'll go with some different colors here. And then we're going to go from 2 to 4. And then, let's see, did I use a green? Nope. And then we're going to go from, from 4 to 6. So we've got these 3 boxes of data that we're looking at. And so with those 3 boxes of data that we're looking at, we're going to go ahead and compute this integral. So we've got this 1/6. We're doing an approximate for the integration. So each of those has a width of 2. So I'll multiply by 2. And then I'm going to have what midpoint sum. So I'm actually looking for midpoints. I'm after this one, and this one. So 1, 3, and 5 are the 3 midpoints. And that's a lot of colors going on, but let's just say t equals 1, t equals 3, and t equals 5 are the midpoints of each of the bands that have a width of 2. So what we're going to do is take those 3 y values and say, well, those are the 3 heights of the approximating rectangles that we're going to use. So 5.3, 11.2, and 13.8. And then what we're going to do is here's our midpoint estimate, and then here's our 1/6 sitting out front of that, which is our average value. So we're going to compute this. So let's see, we add these up. We have 5, 11, 13, and again, this is no calculator, so let's see, that would be 24, 29, the 0.2 and the 0.8 gets to 30, and we'd have 30.3. And so we have a 1/6 times a 30 times 2 times 30.3, so 1/6 times 60.6, and then I can tell I'm probably on the right track here because 60.6 times 1/6 is 10.1. And then we have to come up with units on this. So the units on this, if we're integrating, we're going to get ounces times time. So when you integrate, you get the area of a rectangle. So that would be length times width, which is ounce minutes, which is a ridiculously non-meaningful thing. But then when you divide by 6, those units are minutes. So we're going to divide that by minutes, and the ounce minutes and minutes cancel, and you just get 10.1 ounces, which is the actual answer. So 10.1 ounces is the average amount of coffee in the cup from time 0 to 6. So that's explaining the meaning in terms of the problem, is that's the average amount of coffee, or of liquid, could be anything, but they're putting coffee in, amount of coffee in the cup from t equals 0 to t equals 6. And you can word that a number of ways, but you need to state that you know it's the average amount of coffee in the cup on this particular time interval. So if you have those 2 pieces, you've got a credit for your explanation of a point. You get a point if you correctly knock out the 60.6 number, and then you get another point if you have the 10.1. In other words, you multiply by a 6. So 1, 2, 3 points. This third point gets tagged with the units as well, so you need the ounces on there. So 10.1 ounces is the average amount of coffee in the cup from t equals 0 to t equals 6. So that takes out part C. And then part D, the amount of coffee in the cup is modeled by this particular equation. So they're giving us an equation to say how much coffee is in there. Using this model, find the rate at which the coffee amount in the cup is changing when t equals 5. So this is actually, in part D, probably the most straightforward piece of the question. They just want you to take a derivative. So b prime, the derivative of 16 goes away. Then we've got a negative 16 times negative 0.4 e to the negative 0.4 t. And that extra 0.4 is just coming from the derivative of the inside, which is this exponent, the negative 0.4 t, when we do the derivative of that. So let's see, again, doing this by hand here, but ultimately figuring out when t is 5. So I'm going to take and plug a 5 in. I need to do negative times a negative, that's a positive, so that's 16. 4.4, just, the number of ways we can write that. I'm just going to, for the time being, leave it as 0.4. And then we have e to the negative 0.4 times 5 would be e to the negative 2. And you're not expected to know that as a decimal, just leave it as e to the negative 2. The 16 times the 0.4 we can write a few different ways. You could write it as a fraction, 16 times 4/10 or 2/5 e to the negative 2, so that would be 32/5 e to the negative 2, or 32 over 5 e squared. Or another way I suppose you could do it would be 16 times 0.4 is 6.4, so you could write it as a decimal, and this is free response, so you can choose to express it in any number of equivalent forms, or another way would be 6.4 over e squared. And I suppose we could throw the units on this. It didn't ask for it, but I think it's good, particularly because they've been doing units in this just to get in that habit. There are no points tagged to the units, but whatever we use here would be ounces per minute because we're looking at a rate of change. And you would just get 1 point for showing the derivative, and then you get 1 point for coming up with any of these numeric answers. And just for whatever it's worth, this last one's the one that they put on the scoring guide, but any of them would be sufficient. So again, idea was you go through the first two out of the scoring guide, track through this one using this video, and those are the first 3 questions in a set of free response. So it should be about 45 minutes of work, plus or minus, depending on how long it takes you on any one question, but you'd be blocked out to get 45 minutes on these 3.